The moon, a celestial marvel, has captivated humanity for millennia. Its silvery glow illuminates our night sky, inspiring countless myths and legends. But every so often, this familiar orb undergoes a dramatic transformation, morphing into a crimson spectacle known as a blood moon. A blood moon occurs during a total lunar eclipse, a celestial alignment where the Earth positions itself directly between the Sun and the Moon. As the Earth casts its shadow upon the lunar surface, the Moon doesn't vanish entirely. Instead, it assumes a reddish-orange hue, as if dipped in the heart of a dying star. This captivating phenomenon isn't a harbinger of doom, as ancient civilizations once believed. Instead, it's a breathtaking display of celestial mechanics and the fascinating interaction between light and Earth's atmosphere. This essay delves into the science behind blood moons, exploring the interplay of light scattering, atmospheric refraction, and our planet's unique atmospheric composition. We'll uncover how these factors conspire to paint the moon in shades of red, dispelling ancient myths with scientific understanding. To understand why the moon turns red during a lunar eclipse, we must first grasp how light travels and interacts with Earth's atmosphere. Sunlight, appearing white to our eyes, comprises a spectrum of colors, each with its own wavelength. When sunlight enters Earth's atmosphere, it collides with gas molecules, dust particles, and water droplets. This interaction causes the sunlight to scatter in different directions. This scattering, known as Rayleigh scattering, is more effective at shorter wavelengths, like blue and violet, which is why we perceive the sky as blue. Longer wavelengths, like red and orange, scatter less, allowing them to penetrate the atmosphere more effectively. During a total lunar eclipse, the Earth blocks direct sunlight from reaching the moon. The only light that illuminates the moon is sunlight that has been filtered and scattered through Earth's atmosphere. As sunlight passes through the Earth's atmosphere, the shorter wavelengths, blue and green, are scattered away, while the longer wavelengths, red and orange, are refracted or bent around the Earth's curvature and cast onto the moon's surface. This phenomenon is similar to what happens during sunrise and sunset, where the sun appears reddish, because we are viewing its light through a thicker layer of atmosphere. A lunar eclipse unfolds in a series of distinct stages, each marked by changes in the moon's appearance. First, we have the penumbral eclipse. The eclipse begins with the penumbral phase, during which the moon enters the Earth's penumbra, the outer, fainter part of its shadow. This phase is often subtle and may go unnoticed. Next is the partial eclipse. As the moon progresses further into the Earth's shadow, it enters the partial eclipse phase. During this stage, a portion of the moon is obscured by the Earth's umbra, the darker central part of its shadow, creating a crescent-shaped shadow on the lunar surface. And then, the total eclipse. The pinnacle of the lunar eclipse is the total eclipse phase, where the moon is fully engulfed by the Earth's umbra. It is during this phase that the moon takes on its characteristic reddish hue. After totality, the eclipse progresses in reverse order, moving back through a partial eclipse and then a penumbral eclipse before the moon is once again bathed in direct sunlight. Section 4. Myths and misconceptions, blood moons, through the lens of history. Throughout history, blood moons have been met with a mixture of awe and apprehension. Many cultures viewed them as ominous portents, associating the reddish hue with blood, fire, or anger. In ancient Mesopotamia, blood moons were believed to be a sign of impending attacks on the king. The Inca civilization interpreted them as a sign of a celestial jaguar attacking and trying to devour the moon. To ward off this perceived threat, they would make noise, shake their spears, and even beat their dogs to make them howl and bark at the moon. While these ancient interpretations arose from a lack of scientific understanding, they highlight the profound impact celestial events had on early civilizations. The predictability of eclipses, however, led to the development of sophisticated calendars and astronomical knowledge in many parts of the ancient world. Conclusion: embracing the elegance of predictable phenomena. Blood moons, once shrouded in superstition and fear, now stand as testaments to the power of scientific inquiry. Understanding the interplay of light, Earth's atmosphere, and celestial mechanics allows us to appreciate these events not as harbingers of doom, but as captivating displays of the natural world's elegance and predictability. As we continue to explore the cosmos, unraveling its mysteries and expanding our knowledge, we gain a deeper appreciation for the intricate workings of the universe and our place within its grand tapestry. When you witness the blood moon on March 13th and 14, remember that you are observing a phenomenon that has captivated humanity for millennia, a celestial ballet choreographed by the laws of physics and illuminated by the long reach of sunlight.